the last 3 months, because of COVID-19, schools have been shut. I hope that these materials that we present today will be beneficial to students in their final year of secondary or high school.
Hello viewers, we shall be considering the topic atomic properties and periodicity in chemistry. Atomic properties and periodicity in chemistry. At the background of this study, we previously learned, or you'll have also known, that the first periodic table was designed by the Russian scientist known as Dmitry Mendeleev. But the modern periodic table that we have today have 8 groups and 7 period. 8 groups and 7 period. What are these atomic properties? The first atomic property is the atomic size. We also have another one known as the atomic radius. The third is the ionization energy. The fourth is electron affinity. And the fifth is what we call the electron negativity. Now, what is this atomic size? Atomic size is the size of an atom. When you look at the various elements have different sizes of atom. Let's look at period 2, for instance. At the period 2, you're going to see lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now, as you move from your left-hand side to your right-hand side of period 2, for instance, you are going to observe there is an increased nuclear charge. The atomic size decreases as you move from your left-hand side to the right-hand side. Why? Because the nuclear charge increases as you move from your left-hand side from lithium to fluorine. Now, the consequence of that is this. The nuclear charge tends to attract the outermost electron closer to the nucleus. It tends to attract the outermost electron closer to the nucleus. Now, the more the nuclear charge, the more the strength of the attraction, and that means the size of the atom will decrease. Now, but as you move down the group, for instance, in group 1, we're going to see hydrogen, lithium, sodium, potassium. There is going to be an increase in atomic size. Why? Because the number of shells increases. Now, despite the increase in nuclear charge, the atomic size increases. Why? Because though the nuclear charge increases, does not have the ability to attract this external electron closer to the center because of the shielding effect of the intermediate shells in between that hinders this the nuclear charge, the nucleus from attracting electron towards the center. The same trend is also seen in atomic radius. The atomic size determines the atomic radius. As you move from your left-hand side of the periodic table to your right-hand side of the periodic table, the atomic size decreases. Now, that also means the atomic radius also decreases. Now, that is also contrary when you move down the group. When you move down the group, for instance, in group 1, hydrogen, lithium, sodium, there is an increase in atomic radius. The same reason that is seen in atomic size is also seen in atomic radius. Now, we'll look at ionization energy. Ionization energy is the minimum amount of energy required to remove electron from the outermost shell of an atom. The minimum amount of energy to remove electron from the outermost shell of a gaseous atom. Now, this minimum amount of energy depends so much on the atomic size. As you move from your left-hand side of the periodic table to your right-hand side, for instance, in period 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, there is a decrease in atomic size. Now, that means the amount of energy required to remove electron from atoms of smaller atomic size is higher than the amount of energy required to remove electron from atoms of bigger atomic size. So ionization energy increases as you move from your left hand side to your right hand side of the periodic table, and it decreases as you move down a group. Now we look at electron affinity. Electron affinity is the energy release when an atom of an element removes electron from the outer shell of another atom and add to its own shell. Now the consequence of this, the atom removing the electron from the outer shell of another atom becomes negatively charged, while the atom that releases that electron to the atom that collects the electron becomes positively charged. Now the negatively charged atoms are known as anions, while the positively charged atoms are known as cations. Now how does this electron affinity changes as you move along the period and as you move down the group? Now the electron affinity also depends on the atomic size. The smaller the size of an atom, the stronger affinity is going to have for electron. Now as you move from your left hand side to your right hand side of the periodic table, for instance in period 2 where you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, you're going to experience a decrease in atomic size. Therefore there is an increase in electron affinity, while as you move down a group, for instance in group 1 where you have hydrogen, lithium, sodium, potassium, there is an increase in atomic size. Therefore there is a decrease in electron affinity. Finally we look at electron negativity. Electron negativity is the ability of an atom in a molecule to pull electron towards itself. Now when you look at, for instance, in hydrochloric acid molecule, it's made up of hydrogen and chlorine bonded together by a single covalent bond. Now this single covalent bond is made up of 2 electrons. Now because chlorine has a stronger electron affinity, this tends to drag the 2 electrons that forms the covalent bond between hydrogen atom and chlorine atom closer to itself. Now that ability of chlorine to pull these 2 electrons closer to itself is known as electron negativity. The consequence of electron negativity is the formation of dipole. Now the hydrogen ion becomes slightly positive while chlorine ion becomes slightly negative. In conclusion, I give you this assignment: arrange the following elements in order of their increasing atomic size: potassium, sodium, lithium, potassium, sodium, and lithium. Thank you for listening.